Okay, welcome, welcome. Thanks for coming. This is actually our very last webinar of the whole class. And so again, thanks for coming. Thanks for watching these. And let me tell you the plan in terms of what we're doing today. So I will always, as always, I'll start out with any questions you might have, and I'm always happy to answer throughout the whole time. And then we're moving to chapter 13, which is the last chapter of the entire class. And that is called ANOVA. So it stands for analysis of variance, but we're not really what we're talking about. Just remember ANOVA. That's the important thing. And then we'll get into the requirements to be able to use ANOVA. Okay. And then finally, I'll go over the ideas of Project 2 because Project 2 is due this week. So you definitely need to, get that going. Hopefully very soon, if you haven't already, send me your draft and then I'll look at your draft and give you lots of comments for improvement so that you can make sure you get pretty good score on your project. Because if you make mistakes and you send the drafts, I can let you know. If you don't send me the drafts, then you just I just lose points for the mistakes. So it's much better to send me your draft. Has to be done. The very latest would be 8 a.m. on this Thursday. Better would be like tomorrow or the next day would be good. Some have already sent it in, which is even better. Or tonight. Um, but that's really important. I'll mention a little bit about the end of the class and kind of what's going on. And that's it. You'll notice there are not a lot of items on our agenda. This will be possibly our shortest webinar of the entire class, and it's our last webinar. So hopefully you'll be okay with that because I like to give a little bit less in the last week because one, you have your project due, and the other is, we're towards the end of the class, and so make sure that you're ready for the last exam, which I call the final, but it's the same amount of points as the rest of them. So that's important. So as always, if you have any questions, you can pop in the chat box and I'll be happy to answer any questions you have. And that could be about anything. I'll do my best on answering about anything. About the class, I should be able to answer. Any questions? Okay, if there aren't questions, I just want to let you know if you think about questions in 20 minutes or whatever, pop in the chat box. I'll still be looking at the chat box to answer questions. So I want to think about what we've already done. Okay, so again, this is our last webinar of the entire course, and at least the last half of the class, it was all about hypothesis testing. And we started out with a hypothesis test for a single population mean. And then we looked at the hypothesis test for a single population proportion. And then we compared two proportions. We looked at hypothesis tests for that. And we compared two means. We looked at a hypothesis test for a difference between two means when one, they were independent and the others, they were dependent. And then after that, we realized that sometimes there may be more than one survey question, and you may have qualitative data, and we looked at chi-square tests. Okay, so we looked at the chi-square test goodness of fit. We looked at the chi-square test for independence, and we looked at the chi-square test for homogeneity. So that had to do with differences in distribution. Okay, and then we talked about correlation. Okay, what haven't we covered yet? What kind of hypothesis test or what might you say, hey, is this right? What haven't we done yet? Okay, there's a bunch, but there's one major one that you hopefully would think about. What don't you know how to do a hypothesis test for? Any thoughts? You can pop in the chat box if you want. Because we don't know how to do a hypothesis test for every different kind of thing. There's one big one left. Any thoughts? I don't see you all jumping in. Okay. So we thought about it. We talked about a proportion, two proportions, and then several proportions when we had chi-squared. We thought about a mean and two means. What's left? I gave you the big hint. Hopefully you know. Okay, I don't see y'all jumping in the chat box. What if we had more than two means? What if, for example, we wanted to find out if there was a difference in the population mean weight from if all the states had the same population mean weight? California versus Connecticut versus Alabama versus Nevada versus, there's a lot of states in America. And we don't know how to do a hypothesis test when you have more than two. Does that make sense? So, kind of what this chapter 13 is all about is to be able to say, what if we have more than two groups and we have a quantitative survey question? Then can we do a hypothesis test to find out whether whether they're all the same or at least there's some differences in terms of the means? Any questions on that in terms of the population means? Okay. And it turns out the test we're going to use is called ANOVA. It's a little confusing because it stands for analysis of variance, even though we're really looking at means. The variance is just in the math behind it, which we'll never talk about in this class, but just trust it, ANOVA. So here's what it does. Okay. So analysis of variance is ANOVA. And it's much easier to just write ANOVA. Everyone capitalizes it because it's an abbreviation. And it tests to see if several, and I'm going to write population means are equal or not. So I want to let you know that for the exam, you are required to use the language that I tell you in the webinar. So write this down, take notes. This is really important so you don't make a mistake. When you're looking at the null hypothesis, H naught, colon, you write down the first mean, mu sub 1, is equal to the second mean, mu sub 2, is equal to, if there were just three of them, you'd write equal mu sub 3. If there were 100 of them, you go dot, dot, dot equals mu sub 100. So basically you do it in symbols and it must be written in symbols. And I just want to remind you, maybe I'll put it up here, is you can write mu. That's how you say mu, the population mean. They make it much bigger. So I want to show you it's easy to do. And then a little subscript button. That's a shift just kind of above to the right of the P is subscript. And that would be, let's say you want a mu sub 2, that would be mu sub 2. So I figured I should tell you how to type that when you're taking the exam, for example. Okay. And it must be in symbols. If you do not use symbols for your H naught, I will take off a lot of points. Okay. H1 must be in words. And at least two of the population means differ from each other, but you should do it in the context of what it is. So if it was the weight in different states, then you would say at least two of the population mean population mean weights in two of the states differ from each other. Any questions on that? And that must be in words. So H naught must be in symbols, H1 must be in words. I'm being very clear in the webinar. So write that down. I'm hoping you all that are watching this are taking notes. Are you taking notes? Put in the chat box. Yes, I'm taking, yes or no. Taking notes. Yes. No, I'm lazy and I'm willing to like lose a lot of points on my exam. So I'm hoping all of you are taking notes. Good. So make sure that on your exam you do what I tell you because AI will not. So it's one of the ways that I keep you all from just using AI and not like listening to the class at all. Okay. So any questions on kind of the analysis of variance idea? Okay. So it turns out we're just going to do one analysis of variance question, one type. Uh, it gets actually very complicated. But if you want to learn more about analysis of variance, then especially since this is our last webinar, then you need to take another statistics class. So like a upper division stats class, and then you'll learn about what this is often called one-way ANOVA. There's something called two-way ANOVA. There's even something called multi-way ANOVA, but we only have so much time in the class, so I try not to, push it too much. So we stick with one-way ANOVA. Just let you know that. All right, so are the requirements. Okay. So there are five requirements, and again, you're taking notes, so write down these requirements. What do you think the probability is that you're going to be asked to write down the requirements on the exam, on the on our final exam that you're going to take? What do you think the probability is that you're going to be asked to write down all the requirements if you take the final exam and read every question? Any guess on the probability that you're going to have to do that? You can pop in the chat box what you think it might be. And as you're doing it, you're probably also going to write down these requirements. Now, see you put in the chat box. Let me read the requirements. The first is all sampling distributions are approximately normal. We're used to that. When you have means and you have a hypothesis test for one or two population means, we had to make sure that the sampling distributions are approximately normal. The way you do that for a test for two different means, we want to make sure both of them had sample size greater than 30. That would mean 31 or more. If we had, okay, or you happen to know that we have a normal distribution for each of them. So if you have 50 different means, then you have to show all 50 of them have sample sizes that are greater than 30, or they're all approximately normal. Okay? So it means big sample sizes because that's a lot if we had 50, for example. Okay? Or you have to just assume we have normality, which is never a good idea, but you know, you have to do it, you have to do it. Okay, the second one is all population standard deviations are equal. Okay, so I want to let you know that is actually very hard to decide. And if you really want to determine that, then as I said just a little while ago, you got to take an upper division statistics class. Okay, because there are ways of deciding, but not in our class. It's too complicated. But it's an assumption, and you are required to know what the requirements are. You are not required to be able to test to see if the requirements are met. Okay? Some, like number one, we have the central limit theorem, but number two, you haven't learned how to do that yet. Okay, number three is there's no bias. Okay? So that we've had for everything we've done in this entire class, that if you have bias, you can't do any statistics that's reasonable. So we have to assume there's no bias. Got it? Okay. Another one is the samples are independent. Okay. That's usually pretty clear whether they are or not. It's not that hard to do it. So what you can't do is ask one person 5 questions because that would be dependent. What you can do is look at 5 different groups and ask each group a question and see if there's a difference in the population mean for the 5 groups. Okay. So that's not too hard. And then all the samples were consistently taken. Okay. Also, not that hard, but you need to pay attention to it. Okay, so that would be like if you did the idea of, asking, you know, people, what their weight is and finding out if there's a difference in population mean weight based on state. Are all the population means the same or not? Then you wouldn't say go to a couple colleges in California and ask, and then go to a brewery in New Mexico and ask, because that would not be consistently taken. Do you see how that would work? Because you're asking in different places, different ways. So you got to make sure you're consistently taking the samples. You got to make sure that you're using the same sampling technique. Okay, and by the way, those who showed up late, make sure you take notes. So I asked you, what is the probability that you're going to be asked to state all the requirements on the exam? Any guess? What do you think that probability will be? Pop in the chat box. Give you another minute, a few seconds. Shouldn't take long yet. So just a number. I don't see y'all jumping in. You should at least guess. Okay. Okay. What do you think the probability is that I will ask you to state the requirements on the exam that comes next week? Okay. So here's the thing. It can never be 110%. It can never be 500%. Hopefully you've understood the statistics well enough that that can never happen. 2000% can't happen. So let me tell you this, it's a 100% probability. So put these in your notes so that you know to type them in when you're asked. And if you type anything different, you're going to lose a lot of points. Got it? If you have a spelling error, I don't care. But if you just make something up, or even worse, if you ask ChatGPT to write down the requirements, I will know because it won't write these five in order. Got it? So write them on your notes. Any questions on that? It's a guarantee it's going to be asked on the written question. Okay, ready to do an example. And again, this is going to be a shorter webinar. We're just going to have one example. So here's the example. All right, so suppose that when I say suppose, by the way, it means I totally made it up, but you can imagine a study being done. So suppose that a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay, the data from this study are shown below. And we have people who are white, people who are black, people who are Hispanic, and people who are other races. And these numbers are the number of miles that the people who were surveyed live from the nearest public library. Okay. And just a note, notice that you do not have to have the same sample size. That's not important. That wasn't one of the requirements. You could have different sample sizes, no problem. Okay, as long as you satisfy all the requirements we wrote. Any questions on the question? Okay. Okay. And by the way, I actually am one of these people. Any guess who I am? So when I made up the numbers, I at least put myself in there. Any guess? I don't hear anyone guessing. You're from Tahoe, you probably could guess because you know about our library. All right, I don't hear it. I'm this guy. I'm white, by the way. Hopefully you can see that in the video. And I live about 2 miles from the nearest public library. Okay. Which I go to, especially in the summer, because then I have time to read. I'm not teaching. Okay. So you'll notice what these numbers are. There were 6 people who were white. First person lived 15 miles from the nearest public library. Next was 4 miles, etc. 4 who were black, 6 were Hispanic, and 4 who were other races. All right. So notice that we want to find out if there's a difference in if all the population means distance from the nearest public library are the same, or maybe they're not all the same. Any questions on that? Okay. This is a looking at four different population means. So you can't use the prior tests that we've done, like test for a single population mean or test for comparing two means when they're independent or dependent, because we got four means here. So this is why for this example, you have to use ANOVA. Notice that the survey question is how far do you live from the nearest public library? And you answer with a number, 2 miles. That's me. Any questions on that? So that makes it a mean and not a proportion. So now it's time to write down the assumptions you need to make in order to perform an ANOVA test. And I'm hoping that you took notes down so you know what they are already. So here they are. Okay, we must assume all four distributions of distance from the nearest public library are approximately normally distributed. We have to assume that because each of the sample sizes are less than 31. We have 6, 4, 6, and 4. None of them are bigger than 30, so we have to assume that the distribution are all approximately normal for each of these four populations. Okay. We have to assume that all population standard deviations are equal. Okay. Notice that we could get the sample standard deviations, but we can't even get the sample standard deviation. So that is always going to be a requirement for us because we don't know how to actually test for that. So you got to include it. We must assume that no bias happened. Okay, simple random sampling. So in particular, notice that it just said a study was done. It didn't talk about anything about how they did the surveying. So that assumption is absolutely clearly needed. And then we must assume that the samples were consistently taken. It's most likely true, but we don't know because it wasn't told. So we must assume that. Any questions on the 5 assumptions that we have to make? And hopefully you wrote those down in your notes because that will be asked for and you will lose lots of points if you get it wrong. All you have to do is write it down. It's not a hard question as long as you've written down. But if you didn't watch the webinar, if you didn't pay attention, you'll have no chance. Or if you use ChatGPT, you have no chance because it won't get these 5. Okay, now we have to show the details on the ANOVA test, and then we have to state the conclusion. So our H naught is that mu sub W, or the population mean distance from the library for white people, is equal to mu sub B, or the population mean distance from the nearest public library for Black people, is equal to mu sub H, which is the population mean distance from the nearest public library for Hispanic people, is equal to mu sub O, which is a population mean population mean distance from the nearest public library for other races. Any questions on H naught? Notice it's in symbols. If you do not put it in symbols, what's going to happen on your exam? If you write it in words instead, what will happen? Yeah, points will be taken off. So you're hearing it. I try to make sure there's no surprises on how I give you points. You have to use what we do in the webinar. Okay, whereas H1, you have to use words. It turns out, going over the table. Okay, these numbers, we'll get to that in a little bit because we're going to have to use it. So this just said the first person asked was white and live 15 miles from the library. That's all that is. For example, this person is Hispanic and lives 5 miles from the nearest library. That's all that table means. Okay. That, by the way, the table, you're certainly not required to have that, all those numbers written because that doesn't happen. That's just an example. So I let you know what's required. Okay. So for example, you have to use symbols for H naught and words for H1, and you have to at least two of those 5 words must be the beginning of your H1. Got it? And then races, that's the example, so that you'll have different things for your exam probably. And then population mean, that must be there. Distance from the nearest public library, that one will differ depending on what the example is. And then differ must be there. Do you see how that works? There's a template here that you have to use. Okay. So I will ask you for the name of the test. Hopefully you all know. What is the name of the test we're using? Pop in the chat box. What's the name of the test? If you took notes, you should all know. It's the whole point of this chapter. So what's the name of the test to be used? The hint is it's an abbreviation. Yeah, ANOVA. I wouldn't take points off if you didn't use all capital letters, but everyone uses all capital. Just let you know that. So ANOVA is the name of the test. The level of significance, we'll let alpha equals 0.05. Pretty much, this is like a sociology kind of question. And pretty much social science people always use 0.05. So I'm going to use 0.05. Okay, the test statistic, it turns out that's a new distribution that we haven't had yet. It's called the F distribution. Okay. And honestly, I have no idea why they use the letter F. Must have stood for something once. So it's the F distribution. And we need to find the test statistic and the p-value. To do that, what do you think we're going to have to do? You should know because we've been doing this for like a month now. So, yeah, we have to go to the calculator. So here is the calculator. What calculator should we use? And you should be cheering and smiling. What number? Yeah, 25. Why should you cheer and smile? Yeah, we're done. This is the very last topic of the entire course in elementary statistics is ANOVA. And there's nothing left. Okay? But just let you know, the exam next week, you have to know all 25 of these because covers everything. So, but this is the last thing that's new to learn, and that is ANOVA. I click on ANOVA. And the way I created this calculator is it says enter the data values separated by commas. For example, 3, 4, 7, 9, -2, 8. Then hit calculate and the F statistic and p-value will be generated for you. Okay, so we have data 1. Data 1. Now we go back to the table. Told you we're going to hit the table again. 15, 4, 11. 9, 3, 2. Data 2. 12, 1, 6, 6. Data 3. 9, 17, 5. 1471 and data 4, 181128. Any questions on entering the data into the calculator? There's no tricks here. Okay, just let you know, I coded this calculator up and it only goes up to data 8. So I will let you know for everything we do in our class, I'm never going to make you look at more than 8 groups, mostly because it's a lot of typing. If you had to, any guess on what you'd have to do? Any thoughts? Okay, I don't see you guessing, so let me tell you. You can go to the spreadsheet and there's ANOVA, and that one is pretty much unlimited. It's a spreadsheet. Okay, or you can use some other calculator too. But just let you know that for this calculator, it only handles up to 8 groups. Okay, because that works for the class, but there are examples when you need more, and then you have to use a different calculator. And then I hit calculate. And there we go. And by the way, here's the picture of the F distribution. It's a skewed right distribution. And it just looks like this. Okay. We have our test statistic. So I'm going to ask you for the test statistic. And the test statistic is F equals, how about 0.3339? And the p-value was p equals 0.080099. 0.80099. Any questions? Any questions on finding the test statistic, which is F, and the p-value? All right, at this point, you should all know how to state the conclusion, at least how to start. How do you start the conclusion given the p-value of 0.080099? See if you can type it in the chat box. The first few words. Maybe first 5 words. Because this is basically what we've been doing for the last month. It's the same first 5 words. And I do want you to use these 5 words. So you're required. So another one to take notes on. Yeah. So there is statistically insignificant evidence. Okay. I want you to promise me that you're going to use those 5 words. Or if the p-value is small, you'd use there is statistically significant evidence. You have to start with those words. Got it? One of the reasons I'm doing this is to make sure you're not using AI, because AI will use slightly different words. Same meaning, but I'll take off points if you don't use these words because I don't want you to use AI. Some of you are using AI and I can tell. And when I can tell using AI, I'm very, very mean about grading. So don't use AI, just do your work. Okay? There is statistically insignificant evidence to conclude that. And now you're used to this. Whenever we have a hypothesis test, after the word that is always H1. So now we can just go to H1 and I can copy and paste it. Copy. And the great thing is, even for your exam, you can do the same thing. You can copy and paste. And then that word at should probably be not capitalized. That's the only change I need to make. So there is statistically insignificant evidence to conclude that at least two of the race's population mean distance from their nearest public library differ. Any questions on the template for the conclusion? Take notes because this is what I expect you to write. By the way, don't write in every example distance from the nearest public library. Don't write the word race because that changes from example to example. But all the rest of the words are the same. Sometimes if the p-value is small, for example, the in goes away and there would be statistically significant evidence to conclude. Any questions on the template for ANOVA? Okay, I would say ANOVA is probably the most commonly used statistical test, hypothesis test in social sciences, in research, for published papers. It's everywhere. So it's really, really important, even though it may not feel as important, it turns out to be a really important statistical test. It's just used all over the place. And I only know that, I'm not a social scientist. I'm a mathematician. But I've asked our sociology, anthropology, those professors, and that's what they've told me. So the requirements in this example, we're right here. And again, remember, this will be on YouTube, so you can always go back and revisit it. Should be easy to find. I mean, you have to wait a little bit after the webinar is over because it takes just half an hour to an hour for YouTube to actually, process the thing. I put it up. It takes me about 15 minutes, and then it takes YouTube about 15 to 45 minutes. Just let you know that. Okay, any questions on this? Okay, so that is the very last thing. And I want to let you know, sometimes you'll see it in a different way, but I want it in this way. I want it stated this way with these words, with at least that maybe I'll even highlight the words that you have to have. So where was that? So those are required words for every example in ANOVA that we do in our class. They're statistically, and maybe actually in shouldn't be highlighted because sometimes it will be in, sometimes it won't be in. So statistically, sometimes it'll be insignificant, sometimes it'll be significant, evidence to conclude that at least two of the, and then it'll be whatever you're talking about, and then population mean, and then it'll be whatever you're talking about, differ. Got it? So those are words I require that you have to have. Any questions on that? Okay. Sometimes you'll see it, but I won't accept it. Is there statistically insignificant evidence to make a conclusion that race is a factor in the distance from the nearest public library? I'm mentioning that because you'll see that in social science sometimes. You'll see the word is a factor. But what I want you to do is I want you to write it this way. Sound fair? And you'll notice some of the words are going to be the same for every example. Any questions on ANOVA? All right, so here's the good news. That is actually the very last thing you need to learn in the entire class. And one example is good enough. They all look similar. Okay. They won't all have the word distance from the nearest public library, but they're all kind of similar ideas. So don't copy and paste, every word of this. So here's the next thing. I'm going to give you the secret word. And the secret word is thank you. Okay. I know it has nothing to do with ANOVA, But we're at the end of the class, so I want to thank you for watching these webinars, coming, and at least being polite. Okay. And I guess I should say secret words because thank you is two words, but put type them in, you'll be fine. So thank you is a secret word for this particular webinar. We have more to do today, but we're done with new statistics. We have a little more, not much. I told you today is probably going to be the shortest webinar of this whole course. So we're very close to done, but we have a little bit more to do. Okay, so that's the secret word. Make sure you put that in your notes too, because you can get the secret word quiz. Also, go look at your grade book. And if there's any secret words you missed, you need to send me your 5 pages of notes from that webinar so that you can get points. Otherwise, you lose 5% for every secret word you missed. Okay, and you have basically until Wednesday of next week. So that's really important. So a question on that real quick. You have to let me know what the question is. So if you didn't get the secret word right, then you go back. You can watch the webinar again in the next 9 days and send me an email with your 5 pages of notes because that is a requirement. Okay, so you have one question was where can you access the secret word? Where can you access the webinars? So there's a couple ways. So let's suppose it was the week 2 webinar. You go to the course, this is modules, by the way. Right now I have it clicked on home, goes right to the modules. And if it was your week 2 secret word, you go to week 2, you go to webinar on chapter 3, and right here, you just click on it. And then you click play and you can watch the whole webinar and take lots of notes. Does that make sense? The other way you can find it is if you go to syllabus. I always have multiple ways of finding everything. And if you go to the, let me find it, archived webinars, do you see? Then this will send you to my YouTube channel. This will send you to the YouTube channel that has all of the webinars, all in one shot. And notice we've had 3 already. We've had 11, 2 the first week, because remember there was and they're in backwards order, sorry, because they just get popped in that way from YouTube. I guess I could change it, but it's easy enough. So notice we started with orientation, then we did the sampling statistics and charts. That was week 1, week 2, week 3, week 4, week 5, read up. Okay. Yeah, 5 pages for anything you missed. Basically, I do that to really, really get you to really want to watch the webinars live or at least by the first week. It's my way of like really making you want to do that. Yeah, less than 5 pages, you get a 0. So write lots of pages. You can write large if you want. Yeah, so just know that's important. Okay. And I don't even care, just make them somewhat relevant to the webinars. Don't just ask ChatGPT to write 5 pages of statistics for you. Make sure they relate to the webinars. Okay. And I recommend doing it before the exam next week because that at least you've studied a little bit on that week. Always good. Okay, good question. Really important. So I want to talk about the project a bit. As I mentioned, the project is due on Sunday. Don't wait until Sunday night though, because hey, if your internet goes down, you're screwed. So I recommend turning it in by Saturday. Kind of think about, pretend the deadline is Saturday, and that way if something goes wrong, you get the extra day. But the if you haven't already sent me your draft, the draft is due on Thursday at 8 a.m. And I want to mention the most common errors people make that I kind of the most common things I have to either type in on the drafts or even worse, I have to type in on the final project when you didn't send me a draft, so I didn't give you a chance. So here they are. So one is state whether you're referring to the population mean difference or the sample mean difference whenever that is what you're referring to. Don't ever use the word just mean or just average. Make sure you have the word population or sample before the word, and you should talk about a difference also. Does that make sense? So make sure that when you're, reading your project, that you have those words set up because it is very important. Otherwise, it doesn't really tell what's going on. Okay, because sample mean and population mean are very different from each other. Okay, the next is don't confuse the level of confidence with the level of significance. Okay, so here's what you cannot do. Do not state that because you used a 95% confidence level, that you're going to use a 5% level of significance. Okay, that does not work because you're allowed to use a 95% confidence level and say a 90% level of significance. That's okay. They don't have to match each other. Okay. You look for the level of confidence. What you need to do is you need to look at the 90% level, the 95% level, the 95% level individually, one at a time. For each of them, you should state the pros and cons for each. And then you're going to choose what's best for the client based on those pros and cons. Any questions on that? That's how you decide on which is the best level of the best level of confidence. Is you look at the pros and cons of each after looking at the intervals and talk about based on your client's needs what works the best. So remember, for the level of confidence, if you have a high, like a 99% level of confidence, sounds great, but you can have a wider margin of error. And that may not work for your client because if it's too wide, you don't have any good information that's going to help your client. But if you go to 90%, you get a smaller margin of error, but you have a higher percent chance of being wrong. And that's an issue for the client. Okay, and you should talk about it in context of your specific survey question. Any questions on deciding on the level of confidence, the confidence level? Okay, whereas the level of significance is based on the type 1 error versus a type 2 error. Okay, and that could either be 1%, 5%, or 10%. Okay, and the type 1 error and type 2 error have nothing to do with the confidence interval. Okay, type 1 and type 2 error about the hypothesis tests. Got it? Okay. So don't just state that you're using a 5% level of significance based on type 1 and type 2 errors. Make sure you go into details. Talk about the errors. Talk about how it's going to harm your client if you have a type 1 error. How it's going to harm your client if you have a type 2 error. This should all be done before you even look at your data. You should write all this out before you even conduct the survey. Okay? Because you're supposed to pick the level of significance before you conduct your survey. Okay? You write down your H0, you write down your H1. You think, oh, how terrible will it be to the client if there's a type 1 error? How terrible will it be for the client if there's a type 2 error? Which is worse? Based on that, what should the level of significance be? And then once you've decided a level of significance, then you go ahead and collect your data. Does that make sense? Any questions on this? Again, these are the most common mistakes people make. Okay. And if you leave this out, that's awful. Okay. It's even worse than saying it wrong. So make sure you talk about it. These are like paragraphs. This is a big part of the project. Okay. Now, um, one more thing I didn't tell you. Okay. Let's suppose you decided to use a 95% confidence interval. Well, you should talk about, hey, if you want to use a 99% with the same margin of error, okay, how large a sample size would you need? Okay. And remember, that has a lot to do. The margin of error is just a multiple of the standard error. So remember, the standard error is the kind of one of the main statistics in this project. And the margin of error is if you have a 95% confidence interval, then you take the standard error, multiply it by 1.96. That's the margin of error. So they're just multiples of each other, simple multiples. Okay. So how large a sample size would you need? There's a little math to do on that, but you're required to do that. You're welcome to get help from a tutor if you need a little bit of help on the math. But we've talked about it weeks ago, but it was all discussed. Okay, so don't leave these things out. These have to be in your project. Okay, here's another thing that a lot of people don't do. The confidence interval is not the same thing as a hypothesis test. Don't say, hey, because of the confidence interval, we know there's a difference. That's what the hypothesis test tells you. The confidence interval is all about how different, how much more the first one is than the second, or how much less the first one is than the second. So you should look at the lower bound of the confidence interval and say, based on the lower bound, what decisions will the client make? Because the lower bound tells you not just that the first is smaller than the second, for example. The first population mean might be the smaller than the second, but it tells you by how much it's likely to be smaller. Do you see the difference? It's not about is it smaller, but it's how much smaller or how much bigger. Okay, then do the same thing with the upper bound. So those should be in completely different sentences. Do not just state the confidence interval and then in one sentence talk about what that means. Okay, you should do sentences on the lower bound and then you should do different sentences on the upper bound. Okay, and again, it's how much different, not just that it is different. Any questions on that? And it's how much less or how much more, not just that it is less or is more. Any questions on that? Okay, these are the most commonly mistaken parts of the project. Okay, and I want to remind you that the focus of this project is the confidence interval and the hypothesis test. That should be most of your paper. And by the way, the standard error is part of the hypothesis test. It's also part of the confidence interval. Okay, so make sure that you've intermingled that. Talk about how they relate. Any questions on that? Okay, there's all kinds of other things you should do when you're talking about the confidence interval and hypothesis test. Most people do those, so I'm not spending quite as much time on that. I've spent time on the things that are most commonly left out. And these are the most commonly left out pieces of the project. So again, very important, that you pay attention to it. Okay, make sure that you follow along what I've just told you and make sure you don't make these mistakes. Okay, there's other mistakes people make, but these are the most common. Okay, and another one I'm noticing, if you think you're doing a random sample, good luck. Okay, you better have a full analysis on why it's random in your paper. And guess what? It's probably wrong. You're not required to do a random sample, but if you say it's random, you better explain why, because it won't be. It's for almost every sample, that's impossible. Okay, you're allowed to use convenience sampling, explain it, talk about the bias, that's fine. You're allowed to use a stratified sample, explain it, talk about the bias, that's fine. You're allowed to use cluster sampling, explain it, talk about the bias, that's fine. Okay, those are the main ones. Okay, if you think you did random sampling, you're probably wrong because that's the biggest mistake that people make on sampling is they think it's random and it's not. Another mistake people make is if the population is not very, very large, this this won't work. Because if the population was, say, 70, then you could just do a survey of all 70. And then there's no reason to do a hypothesis test and a confidence interval because you can just get the whole population. So make sure that your population, and you should identify what your population is. And that might be, say, all college students in California. And that is in the millions, so there's no problem with that. Do you see that? But if it was, say, all baseball teams in the national, in the, in the different professional, I forget the name. I'm not a big baseball person, but then that wouldn't be enough because there aren't that many baseball teams. Does that make sense? That are in the professional major league, that's what it is, Major League Baseball. There wouldn't be enough. So if there aren't enough, or if it was, say, statistics students at Lake Tahoe Community College, there aren't enough of them. Okay. We probably have, I don't know, 60 statistics students at our college, maybe 100, but not enough. Does that make sense? So, but if it was all statistics students in California, that's fine. Do you see that? So make sure that your population is large enough. And then your sample needs to be greater than 30, so at least 31 for each group. So if you have two groups, then you have to have at least 31 of one, and at least 31 of the other. And by the way, having 500, that's not helping you at all. There's no reason to do that. It's just messy work. Okay. The other thing to make sure you do is copy and paste the columns from the spreadsheet for this class. It has to be this class's spreadsheet, not the calculator for the class, but the spreadsheet that we use for project one and project two. Okay. And that has to be in your project or you lose a lot of points. Okay, so that's pretty much it. An hour is probably pretty much was my plan in terms of what we're going to do. I'm always happy to answer questions, and thank you all for watching these webinars. This is the very last webinar of the entire course. Okay, it doesn't mean I won't have office hours. I won't have office hours on Thursday because that's a holiday, and I'm not supposed to work on Thursday. Okay, I still do online stuff, but just let you know, I'll still probably do a project. You know, I'll look at your projects, but I'm not supposed to have office hours Thursday because it's a holiday. It's June 19th, it's a Juneteenth holiday. So I think the college is closed actually. Okay, there's no classes. So I'm pretty sure we're closed. But I do have office hours on Wednesday and on Friday, and then I'll have them on Monday and Wednesday next week also. And then we're done, by the way. Wednesday is your very week from Wednesday is your very last day to do anything in this class. And by the way, there is no extra credit. There is no extra credit in the class. Don't ask. If you ask, I'll say no. So there's no reason to even ask. There's no extra credit in this class. You can't do late assignments if they already happened. You can't turn them in. It's too late for that. Okay, if you haven't already turned, if the due date's already over, it's too late. Okay, so that's about it. But I'm always happy to answer questions. I'm going to stop the recording. Thank you all for being part of these webinars, and I'm going to stop the recording.